Hi, welcome to Science for Schools. Today we're continuing through 2014 Ordinary Level Paper 1, moving on to question 9 today. And this question is all about functions and calculus. In this question we're told about this rocket that's fired into the air and comes back to the ground. We're given this function that describes how high up the rocket is after a given amount of time, and we have to use that to complete this table that we're given, and some of these are already filled in. So what we have to do is say, well, what happens to this function when the time is, for example, 0 seconds? So what is h of 0? That's 10 times 0 minus 0 squared, replacing t with 0, and that's 0. So it is 0 high at 0 seconds. What if we try time is 1 second? We say 10 times 1 minus 1 squared, and that's going to be 10 minus 1, which is 9. So you put a 9 into that table. So let's put in a few more. We do h of 2. That gets us 10 times 2 minus 2 squared, which turns out to be 16. h of 3 is 10 times 3 minus 3 squared, which is 30 minus 9, and that is 21. So you can put 21 in there. And you might notice there's a bit of a pattern emerging here, that there's a 16 and a 21 here, and over the other side, at 7 and 8 seconds, we've got 21 and then 16. This might be something you've seen before, that quadratic functions like h are symmetric about the middle. And if you can find the middle, then that kind of cuts your work in half. So what we could do is try and figure out what is h of 4, or we can just recognize that it's symmetric about this middle here, which is 5 seconds in. And so the height must be 24 at 4 seconds. But let's verify that. So what's h of 4? It's 10 times 4 minus 4 squared, which does turn out to be 24. You can then cut your work down a little bit more at the end here by filling in the 9 and 10 automatically, because you know it's going to be symmetric again. So it's left of 16 over here is going to be the same as the right of 16 over here. So that's going to be a 9 and a 0. And it doesn't hurt to try and verify these if you have time left over. So let's say that's 10 times 9 minus 9 squared, which does turn out to be 9. That's 90 minus 81. Then h of 10 is going to be 10 times 10 minus 10 squared. So that's going to turn out to be 0. And so the whole thing works out, and you can see it's absolutely symmetric about the middle, which is at 5 seconds. Part B is asking us to use the data we just got from Part A and represent that as a graph where we have time on the x-axis and the height on the y-axis. Since we're plotting the time and height on two different axes, we can actually take these as being coordinates. For example, the first point here where we have time is 0 and the height is 0 at the same point. The coordinate version of that is 0, 0, which is right here. We can do that with the next point as well. So where time is 1 second, the height is 9. So there's 1 second, and we have a point at the height is 9. And we can continue with this. We've got 216 is another point. 321 is going to be there. 424. 525, and you can work out the rest of the coordinates, or you can just say it's going to be symmetric about the middle, and so you can just draw this mirror image of the same shape to the right. Now the points on this are not quite the answer, because the rocket will actually have a height in between all of the points that you've plotted, and so we have to try and draw a curve to fit all these. And you should be familiar with what a quadratic curve looks like. It's a kind of either a U shape or an N shape. In this case it's an N shape because of the minus t squared. And you have to forgive my drawing, it's very difficult to draw curves like this on a tablet. But it should end up looking roughly like that. Part C asks us to use our graph to try and get a bit more information. Says to find the height of the rocket after 2.5 seconds. it's not something that we calculated because we only did the integer values of time. We did 2 seconds and 3 seconds. We didn't do 2.5. So to work out what happens when it's 2.5 seconds, we start with 2.5 seconds on the time axis and draw a line upwards to hit the graph, and then draw a line across to hit the height axis, and make sure you draw little arrows on these just to show that you know what way you're going on these. And so that looks to be pretty close to 19 meters, so maybe 18.7 meters or so. Let's say 18.7 meters. And depending on the quality of your graph, you're going to end up with slightly different answers, but they do accept a bit of variety, and it is meant to depend on your graph. We're then asked to estimate the time when the rocket will again be at this height. So when is the rocket going to be at 18.7 meters again? Well, here's the first time, 2.5 seconds. And so we go across until we hit the graph again, then go back down to the time axis because we're asked to work out what time it's going to happen at. And again, put little arrows on it to show you know what you're doing. So that looks to be about 7.4 seconds. Lastly, the coordinates of the highest point reached by the rocket. We can tell this from the graph because the height of the rocket is just given by the y-axis. So where's the point that's furthest on the y-axis? It's right here. And what are the coordinates of that point? I mean, we already know what they are because they're coordinates that we've worked out, but we can use the graph as well to read the points off the axes. Don't forget your arrows as well, just to show you know what you're doing. So the coordinates are 5, 25. Don't forget to put in both coordinates because it wasn't just asking for when it happens, or it wasn't just asking how high does the rocket go. It's asking for both coordinates in the one question. We're then asked in part D to find the slope of the line joining the points 6, 24 and 721. We can use the slope formula for that, which is y2 minus y1 over x2 minus x1. And we've got to label our points. Let's call that x1 and y1, and this x2, y2. Substitute them in. That's going to be 21 minus 24 divided by 7 minus 6, and that's minus 3. The second part of B asks us to compare two lines and ask which one would we expect is steeper. We can actually try and plot both of these lines back on the graph above. So we have one line going between 624 and 721, that's this green one. And the other line goes between 721 and 816, that's the orange one. And it asks which one is going to be steeper. So which one is changing how high it is quicker? Say, if you're trying to drive up one of these slopes, which one would be tougher? To me, it looks like the orange one is steeper because it's closer to vertical, which is what we would usually say is the ultimate in steepness. But we can work it out a little bit differently because the steepness of the lines is determined by their slopes. We already know the slope of one of these because in the first part it asks us to join 624 and 721 and work out the slope of that line. If we work out the slope of this other line between 721 and 816, that will ultimately tell us which is the steeper line. So work out the slope. Let's say in this case we'll keep x2, y2 we had above, and we'll switch x1, y1 to 816. We end up with 21 minus 16 over 7 minus 8, which is going to be minus 5. And even though, like on a number line, minus 5 is technically less than minus 3, it's really the absolute value, the magnitude of this number, how big the number part of it is, that determines how steep it is. So we would say that the line the line between 721 and 816 is steeper, because its slope has a larger magnitude. And we might as well include then that of the line between the other 2 points, 624 and 721. So since minus 5 is a bigger absolute number than minus 3, then that is the steeper line ultimately. Part E asks us to first of all find dh dt, that is the derivative of the height with respect to time. But the original height is given by 10t minus t squared, so we have to find the derivative of this, differentiate it with respect to t. We end up with 10 minus 2t. With that information, we're asked to find the maximum height reached by the rocket. When you see the word maximum, you should hear these alarm bells in your head saying the first derivative equals 0. Anytime you see maximum, minimum, biggest, smallest, tallest, shortest, anything that's the most or the least of some kind of quantity, you're talking about the first derivative equaling 0. So we're saying 10 minus 2t equals 0, because we're looking at the maximum, in which case 10 is equal to 2t. So 5 is the time. That is not the maximum height reached by the rocket, that is the time at which the height is a maximum. To find the maximum height then, you have to put it back into the original height formula, which is 10t minus t squared. That's 10 times 5 minus 5 squared, or 50 minus 25, which is 25 meters. Finally, with this question, we're asked to find the speed of the rocket after 3 seconds. And you should know from the rates of change section of your course that the speed is given by the derivative of its position or displacement or distance traveled with respect to time, which in this case is essentially the height. So we can say dh dt is the same as the speed, so speed equals that. So if we're looking for 3 seconds in, we just put 3 in for time. That's 10 minus 2 times 3. Remember, we already have 10 minus 2t is the derivative. That's 10 minus 6, or 4 meters per second. Don't forget your units with these. You will lose marks if you don't include them. The very last part of this question asks us to find the coordinates of the point at which the slope of the tangent to the graph is 2. Once again, we have to rely on the derivative. The derivative not only tells us the speed, but it also tells us the slope of the tangent to the graph. So we have that is 10 minus 2t, and we know that that's equal to 2 because that's the particular situation that we're interested in looking at. So we play around with the algebra here. We end up with 10 minus 2 equals 2t. That's 8 equals 2t. And then 4 seconds equals the time. Now this 4 seconds is only one of the coordinates. That's the x coordinate of the point. We now need to work out what is the y coordinate, or what is the height of the rocket at 4 seconds. We can pull it from that table we had at the beginning, or we can calculate it again. h of 4 is given by 10 times 4 minus 4 squared. That's 40 minus 16, which is 24. And so the coordinates of the point are 4, 24. So that's the whole question done. Thank you very much for watching, and hopefully I'll see you in paper 2.